All right, hello everyone. This is lesson number 49. This is laws of exponents. Make sure you're following along with your notes, either if you're able to print it or if you're following along on a sheet of notebook paper. If you're watching this on Edpuzzle, I'm able to see that you watched it. If not, if you're watching on YouTube because Edpuzzle doesn't work for you, do make sure that you send me your notes so that I don't mark it as a missing assignment for you. Okay, so here's where we're at on the calendar. We're sticking to one lesson a week just to make it a lighter load on y'all to balance all of your classes. This is the 27th, the week of the 27th. So this week's lesson is laws of exponents. This is the video, and there will be a practice associated with it. Friday is actually an inclement weather day, no school. If you want to turn in the practice by Friday, that'll be the deadline. If you turn it in Thursday, that's fine. But if you need an extra day, you can turn it in Friday. I won't grade them until the weekend. So Friday will be the day where the practice is due. But you can turn it on Thursday, Wednesday, Tuesday, or Monday, whatever works for you. Okay? Then next week we'll have a lesson that's a continuation of this lesson, which will be solving equations with rational exponents. There'll be one lesson on that. And then because the following week AP exam starts, we will have covered and finished all material here. But because AP exams week start, I'm going to just do review for this so you can focus on your AP exams. And then ACP testing, I still haven't gotten any information on what is going to be in lieu of ACP testing, since there won't be that if we're not testing at all or what. But as soon as I find out that information, I will communicate that to you. So I thought it'd be good to start with a video. This is something I was going to show y'all with relation to the third goal, never give up. When we were in school after the break, but we didn't get to it, so I thought I'd show it to you now. This is one of my favorite commercials. You may have seen it. It's a Powerade commercial, so I just want you to watch it and think about it. If I can play it.
Wouldn't ask why the rose that grew from the concrete had damaged petals. On the contrary, we would all celebrate its tenacity. We would all love its will to reach the sun. Well, we are the roses. This is the concrete. These are my damaged petals. This is the concrete. Don't ask me why. Ask me how. Ask me why. Ask me how.
So I'm not sure if you've seen that commercial or not, but and if you know who that is or who the author is of that poem. If you don't know context, obviously it's a Powerade commercial. This is Derrick Rose, who is from Chicago, Inglewood, Chicago to be specific. He's a basketball player who played for the Bulls, and just a great player who had to overcome a lot of adversity, both in his personal life growing up, but also in the league. He tore, I think his ACL or something like that, twice, I believe. So that's what the poem is. He's using him as an example, but I'm curious if anybody knows who the author of this poem is. It's kind of a famous poem by Tupac, actually. So Tupac wrote this poem, and it was actually released after he died in an album called The Rose That Grew from the Concrete, which had a collection of his poems, and one of which was this one. So I want to read the full poem, and just want you to think about a key takeaway or something that sticks out to you from this poem. I think it's powerful. So it says, "Did you hear about the rose that grew from a crack in the concrete? Proving nature's law is wrong. It learned to walk without having feet. Funny it seems, but by keeping its dreams, it learned to breathe fresh air. Long live the rose that grew from the concrete when no one else ever cared. You see, you wouldn't ask why the rose that grew from the concrete had damaged petals. On the contrary, we would all celebrate its tenacity. We would all love its will to reach the sun. While we are the roses, this is the concrete, and these are my damaged petals. Don't ask me why, ask me how. So as you think about that poem, I think it's a powerful poem and it has a lot of meaning to it. I want you to think about what's one particular part that sticks out to you and why, or how do you understand this poem? So to me, the way that I understood the poem is, it can, there's a lot to it, but a few things that stuck out to me was just this concept of a rose that grew from the crack in the concrete, right? So like the way I see this is concrete representing being in the inner city, right? And a rose growing from a crack in the concrete, having to overcome a lot of obstacles that come with the challenges of that. Maybe growing up in poverty or growing up with different challenges or crime or things like that. And just this concept of proving nature's law is wrong. Like society or others may have seen Tupac or seen Derrick Rose and said his destiny is not to be successful. And to prove that wrong by keeping the dreams and being a rose who ultimately flourishes through a challenging situation is just a beautiful thing to picture. And just this concept of don't ask me why, ask me how. Just thinking about that in the context of like when you see someone, Tupac particularly, he had an interview where he talked about this poem, and he talked about when people see him, they oftentimes see the rough edges that he may have, and they point out those things instead of the tenacity and the things he had to overcome to be the person that he is, and how he had to not give up in the face of difficult circumstances. Like his mom, I believe, was on drugs, and he left the home for a while, and just a number of things, growing up in poverty. And oftentimes they see him being rough around the edges more than they do see his tenacity to overcome and who he is and who he became in inspiring millions. And so just something, a poem I wanted to share because a poem I really love. So all right, we'll go ahead and get started. We will learn math, build character, never give up, and ask why. All right, so this lesson is on laws of exponents, which is actually something you learn about in Algebra 1, but it is foundational for the lesson we're doing next class, and it comes up a lot on the SAT as well, so I wanted to revisit it. Here's 3 SAT questions that we're going to come back to at the end of this, and we're going to do these 3. There are 3 different levels of difficulty, but it does come up on the SAT a lot, so we're going to come back to those. But first, I want to just refresh your memory on what the laws of exponents are. They are in your formula sheet for Algebra 2. They are not for the SAT, however. So this is basically the rules by which you multiply, divide, and do different operations with exponents that have the same base. So the first is the product, which states if the bases are the same and you're multiplying them, you add the exponents, okay? Then you have the quotient, which if the bases are the same, you subtract the exponents when it's dividing. You have the power, which states if you have an exponent to an exponent, you would multiply them. Okay? And then you have the negative exponent rule, which is where if you have a negative exponent, it will go to the bottom. And the rational exponent, which if it is a fraction as the exponent, it can be written as a radical. That's a lot of information. We're going to look at examples of each of those, but that's the general overview. There's an acronym that can help, which is MADSPM, which basically means when you're multiplying, you add the exponents. So that's this case. Multiplication, add the exponents. When you divide, this case, you subtract the exponents. That's this. When it's a power, so an exponent to an exponent, you multiply the exponents. So MADSPM, that might help when you don't have this formula sheet. Multiply, you add the exponents. Divide, subtract the exponents. Power, you multiply the exponents. Just an acronym to help. So let's look at a few simple examples of how you would simplify using the power or using these properties. So let's start with this first one, the product. So in this case, if you have x to the power 3 times x to the power 2, it's important to note if this was a y and they were different bases, you cannot use this property. The bases have to be the same. So if it's an x, it has to be x on both of these. So because these bases are the same and they're being multiplied, this is telling us that we can add the exponents. So 3 plus 2 would be 5, so this would be x to the power 5. The reason why that works is because if you were to expand out x to the power 3, that just means x times x times x, 3 times, right? And then if you were to do x to the power of 2, that would mean x times x. And altogether we have 1, 2, 3, 4, 5 x's being multiplied, which is the same thing as x to the power 5. So that's why that works, why you're adding, okay? For the division rule, or quotient, that's the second one here, that states when it is division, you subtract the exponents. So in this case, you have 4 as an exponent and 2 as an exponent. The bases are the same. If you subtract, you get x to the power of 2, because 4 minus 2 is 2. Similar process here in trying to understand why that works. At the top, you have x times x times x times x 4 times. At the bottom, you have x times x 2 times. And what happens here is that these end up crossing out, because they're at the top and bottom, they would divide to give you 1. And you are left with x squared, or 2 x's there. So that's why that works. Okay? The negative exponent rule is if you have an exponent that is negative, then it's going to go to the denominator. Okay? So to help you understand why that is, we're going to look at this example here. So this is division. There's no negative exponent. But what will happen is, because it's division, we would have to use the quotient property, which tells us we would subtract the exponents. But 2 minus 4 would give you negative 2, right? X to the power of negative 2. So because that is a negative exponent, if we're following this, it will equal 1 over, and then this is going to go to the bottom, so 1 over x squared. That would be how it will be written, simplified, okay? What I put 2, 1 over x squared. Now, the reason why that ends up going to the bottom when it's negative is because if you expand this out, you have 2 x's at the top. And you have 4 x's at the bottom. And what ends up happening is if you cross these out, these 2 x's that are remaining are at the bottom, right? And at the top is just 1. So that's why it ends up being, when it's a negative exponent, it goes to the bottom, okay? Now, one thing to note here, let's say that it was 5x to the power negative 2, then that would be written as 5 over x squared, because the 5 exponent is just 1. It's just not visible, okay? So the 5 would stay at the top. The 5 will go to the bottom if it was in parentheses, like this, say. Then that would be written as 1 over 5x squared, because in this case, the 5 is also being raised to the negative because of the parentheses. So that's an important distinction to make there. The reason why this one has a 1 is because the number in front is just 1, so it's just going to stay as 1 at the top. Okay, the last case is when you have an exponent to an exponent. We're using the power property, which says that we're going to multiply them. So this times this will be 6. So x to the power of 6. 3 times 2 is 6. Okay? Now, the reason why that works is because this is like saying you have x squared times x squared times x squared. This is 3 times that you have that. And if you break this down more, this is x times x, this is x times x, and this is x times x. Altogether, you have 1, 2, 3, 4, 5, 6 x's. So that's x to the power of 6. Okay? So and we'll talk about the rational exponent at the end of the lesson. I want to isolate that one on its own. But those are the first 4. Okay? So let's try some problems. So we're just going to simplify these by using the laws of exponents. One thing to note here, so now we're just adding some stuff here. We have a coefficients here. We have these regular numbers out front. With those numbers, we're going to treat them normally. So whatever operation we see, we're doing that operation. So for example, here it's a multiplication. So this 2 and this 5, we're just going to multiply normally. 2 times 5 is 10. This x to the power 2 and this x to the power 3, since it's multiplication, we are using this property, right? It's multiplication. which tells us we add the exponent. So you can think multiply a, madspum, multiply, add. So x sub 2 plus 3, x to the power of 5. And that's simplified. Okay? Let's try another one. So this one is division. So then we're using quotient property. We're going to deal with these numbers in front. They are coefficients. Coefficients we're treating normally, doing whatever operation we see. So 4 divided by 2 is 2. Then, if whichever ones have the same base, the rule is when you're dividing, you subtract the exponents. So in this case, these have the same base. So x to the power 4 divided by x to the power 3. 4 minus 3 gives us 1, so that's x to the power 1. But you don't have to write 1, that's understood to be there. X is fine. Here, you have y at the top and y at the bottom. Those have a common base. 3 minus 5 is negative 2. So y to the power negative 2. Now, you want to notice that you have a negative exponent here, so that goes to the bottom. So it's going to be written as 2x over y squared. Only the y squared goes to the bottom because only the y has an exponent that is negative. This will be your simplified answer. Let's say you get confused within that. You could always do this as well. You can write out, okay, at the top I have 4 x's. X, 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 x. Then I have 3 y's. 1, 2, 3. Then at the bottom I have x, 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 3 x's. And I have 5 y's. 1, 2, 3, 4, 5. You can cross out this, this, and this. You can cross out the y over y, y over y, y over y. And you have an x at the top, which is this one. You have 2 y's at the bottom, which is this. And then the 4 divided by 2 would give you the 2 there. So you can also do that. But that's just a longer process, but it will give you a way to check your work. Okay, so let's look at this one. We have a number in front that we're going to treat that number normally. So we can think about it one of two ways. We can do 2 to the power of 3, which would give you 8. Or if you think you're going to forget, you can just write an exponent of 1. And because these are a power to a power here, you will be using the power property, which tells you that you multiply. So 1 times 3, 2 to the power of 3. You can think about it like that too, which is still going to give you that 8. And then 2 times 3 here is 6. So x to the power 6. So that's simplified. Okay. So here we don't have a coefficient, but we have a power to a power. So we're going to multiply according to the power rule. So that times that, x to the power 6. That times that, y to the power negative 8. And note that we have a negative exponent. So this will go to the bottom. So it would be x to the power 6 over y to the power 8. That's using the laws of exponents there. Hopefully you remember this. Might have been a while. This is just recap. Okay, let's just try a couple more examples. Another thing to note, anything to the power of 0, if you remember, equals 1. So it doesn't matter whatever you put in here, that whole thing to the power of 0, that's just going to be 1. Okay? Because no matter what these numbers are, anything to the power of 0 is 1, except for 0 to the power of 0 that doesn't exist. Okay. Now here, if we're simplifying this, one thing to note is this is the same thing as x squared to the power 3 over y to the power 4 to the power 3. Same thing, either way. So we can go ahead and multiply this. Power to the power, you multiply. That's x to the power 6. 4 times 3, 12. That's going to be y to the power 12. And that's all you could do there. All right. Last example here. The coefficients, treat them normally. We're dividing. 30 divided by negative 5, negative 6. Then here we have y and y, top and bottom. The rule when you're dividing is you subtract the exponents. 4 minus 2, 2. So that'd be y to the power 2. Now, we got to be careful with this one here, because it's at the bottom, but the exponent is negative. So here's how we want to think about that. At the top, we don't have any x's. So we could write, instead of nothing there, we could write x to the power of 0, because anything to the power of 0 is 1. So it's like, just so I can have a variable there, I'm going to put x to the power of 0. And then what we can do is use the quotient property, which states when you divide, you subtract the exponents. So 0 minus negative 4 would be, this would change to plus, so it would be 4. So when you divide these, it would be x to the power of 4. Okay? Or in other words, if the negative is on the bottom, it would flip to the top. Okay? All right. Let me know if you have questions so far. I always try to go back and read through the Edpuzzle responses and comments, and I reply if there's a question or anything like that at the end of the week. Or I try to do it in the middle of the week. Okay, so that is this product property, quotient property, negative exponent, power property. Let's just talk about this last one, the rational exponent, okay? So the rational exponent helps you to see that if you have an exponent that's a fraction, it can be written as a radical. And this is the main one we're going to be using for next lesson as well. So let's say you have the square root of 4. That is equal to 2, all right? 2 times 2 is 4, so the square root of 4 is 2. The cube root of 8 is equal to 2. This one right here, one thing to note, when you don't have a root here, then the number is understood to be 2. That's why it's called square root, right? So this is a 2 whenever there's no number there. So over here, this is a 2 right here, whenever there's no number there. Because that's why it's the square root of 4, square being 2. So if we were trying to solve this, it would be the square root of 2 to the power of 4 would be 2 times 2 times 2 times 2. That would be 16. So that would equal 4. Okay. In this case, this is also square root. So the number understood to be there is 2. Square root of 16. What times what twice gives you 16? 4. Okay. Now, if we wanted to apply this, to rewrite this from a radical, because currently they're all in radical form, to a rational exponent, if you take note here, the m is always the exponent inside of the radical. In this case, in this first example, we don't see an exponent, so that's just 4 to the power 1, because 4 to the power 1 is 4. So this 1 is the m. If you notice, the n is the root, so in this case, the n would be 2. So if we were to rewrite that as a to the power of m over n, oh, and a is just the number there, it would be 4 to the power of, our m is going to go at the top, which in this case is 1, over the root, the n goes at the bottom, the n is 2, 4 to the power 1 over 2. So square root of 4 can also be written as 4 to the power 1 over 2. If you put 4 to the power 1 over 2 in your calculator, it would also equal 2. So radical can be written as a rational exponent. Okay. Here's an acronym or a phrase to help you remember if it helps. Numerator needy, denominator determined to leave. What do I mean by that? Let's say you had it like this, 4 to the power 1/2, and you were trying to write it as a radical. You could remember the numerator is needy, so if 4 is here, numerator needy, the numerator has to stay here. It's needy, it wants to be close to the 4. Denominator is determined to leave, so this denominator is determined to leave the 4, so it wants to go out. Just a random thing to help you maybe remember. Numerator needy, stays close. Denominator is determined to leave. The denominator goes out here. And those are how you would write it. Okay? So let's try another one. So if there's no exponent here, the exponent is 1. So if we were writing this as an exponent, 8 to the power of m over n. So this one, go up here, 1 over 3. So this one would be 2 to the power of, this is m, this is n, right? So 4 over 2, which would be 2 to the power of, 4 divided by 2, we could simplify in this case to give you 2. And so no, all of these are going to be equal. Like 2 to the power 2 is equal to that. 8 to the power 1 over 3, if you put that in the calculator, would be equal to 2. Last one, this one, you have an exponent of 1. That would be 16 to the power of 1 over 2. If you put that in the calculator, it would equal 4. So every radical can be written as a rational exponent. So let's work backwards real quick. So let's say you have it as a rational exponent and you want to write it as a radical. You can remember the acronym or you can just look at this. So acronym, numerator needy. So you have the x in here. The numerator is needy, it needs to stay close. The denominator is determined to leave, it's going to go out here. That helps you can think about it like that. Same thing here. 25 here. Numerator needy, it needs to stay here 1. Denominator determined to leave is going to go out here. Now we can write that more simplified. Because 25 to the power 1 is redundant. We can just say 25. This 2 right here, square root, is understood. So we don't have to write the 2 here. Unless if it's a number other than 2. Like the 5. One more. This one would be 27. And then numerator needy is going to stay here. Denominator determined to leave is going to go out there. We could simplify this if we wanted to and do 27 squared. But it's okay. We'll leave it like that. Okay, so let's try these 3 on the right, and then I'll give you some to try on your own. So this one is in radical form. You want to write it as a rational exponent. The exponent of this x is 1. And by the way, you can pause the video at any time and try it yourself and then play to see if you got it right, if that helps. So you're going to write this as x. This is the m. This, right? It's going to go at the top. So 1. This out here. 4 is the n, it's going to go on the bottom, so 1 over 4. So we're just rewriting interchangeably between a radical form and rational exponent form. So this one would be 4 to the power of 2 over 3. This one we don't have any numbers visible, so we would remember that this exponent is 1 if there's no exponent. This is a square root, so it's 2 if there's no visible one. So this would be x to the power of 1/2. So that's how you go from rational exponent to radical. So I want y'all to try one. I want you to try this one here. So what radical matches this rational exponent? So take a minute and try that. All right, you should have ended up with B. B is correct. Okay. Take note, if you chose A, the A wouldn't be right because this 7 is actually a coefficient. It's not a root. This is in front, and there would be a 2 right here. Okay, try this one. All right, so on this one, it looks slightly different, and this might be important to note here. The answer is going to be, 3 over 2. The answer is going to be C, okay? This 3 is outside of the radical, which may seem confusing. But technically, you can put it inside the radical in this case, because if you think about it, let's just isolate this, square root of x. And we'll deal with this 3 later. The exponent here is 1, and this root is 2. If you rewrite that as a rational exponent, it's x to the power of 1 over 2, right? And then this whole thing was raised to the power of 3. So we can take this 3, raise it to the power of 3. Then if we think about the power property, that states you're multiplying the two exponents because they're being raised to each other. When you multiply 1/2 times 3, that's 3 over 1. 3 times 1 is 3. Wait, I'm sorry, this is half. 1/2 times 3. So this is 3 over 1. So 1 times 3 is 3. 2 times 1 is 2. So that's 3 over 2. So this is x to the power of 3 over 2. So you really could take this 3 and put it in here and write it as that, and it would be the same thing. And then when you rewrite that, it would be x to the power of 3 over 2. So you could bring that 3 in like that. So if it's on the outside of the parentheses, technically it's going to work out to where it would be the same as it is on the inside in this case. Okay. All right. I want to go back to those SAT problems. This was the ones that we started with, and I want to close with those and try them. So here is the first one. And with the Ed puzzle videos, don't stress too much on if you get them right or wrong. The embedded questions, try them, but the goal is just for you to try and get feedback immediately. Some of y'all send me a message like if you get something wrong, asking is it going to count against you? It's not going to count against you to hurt you. It's just I look back at those at the end because they help me to see where we on track, where we understanding generally as a class as I look at the kind of individual answer. So don't stress too much if you get any of these wrong, but go ahead and try this one and put what your answer is. Okay, so this one is a simpler example of how you could see it on SAT. This is just how would you rewrite this? And so this would be written as the cube root of a squared, right? So that would be d. That's just straight up rewriting it to see what is equivalent or equal to that. Okay. The last two are a little bit more challenging. You gotta put together some other stuff that we learned, but I want you to try it. So go ahead and try this one. All right. So on this one, you have this information that says 3x minus y equals 12, and it says what is the value of 8 to the power of x divided by 2 to the power of y. There's a couple different ways you can do it, okay? So one way is you can't subtract the exponents here, by the way, even though it's division, because the bases are not the same. What you can do is make the base the same. So this is going back to an earlier lesson we learned. So you can change the 8 to a base of 2 and make it 2 to the power of 3. And then you have this x still out here as an exponent. And bring this down. And then this you can rewrite, or you can multiply those because that's the power property. 2 to the power of 3x over 2 to the power of y, right? And then now that the bases are the same, you could subtract the exponents. And so it would be 2, base stays the same. This stays the same. To the power of 3x minus y when you subtract. And that's why over here it tells you 3x minus y equals 12. So then this whole thing equals 12. And then you have the 2 right here. Okay? So that's one way to do it. Another way to do it would be like to figure out what number for x and what number for y when you plug it in will make it equal 12. And then plug those same numbers in here and see which one is equal. In my opinion, that might be a longer problem. Also, you don't know whether this is on a no calculator or a calculator section of the SAT. So you would need a calculator to do 2 to the power of 12. It would take a little bit too long without. So that would be one method. There is another method, but I would think this one is the easiest. So we'll stick to that. All right, the last one is probably the hardest of the three, but I want you to go ahead and try it and see if you can figure it out. Okay. So in this one, you had to remember difference of squares. So a lot of information going on here. We're just going to start over here with this piece right here. So let's simplify this. Because you have division, the bases are the same here. You can subtract the exponent. So we're going to rewrite this as x to the power a squared minus b squared equals x to the power 16. Okay? And the reason why it tells you this over here is just a restriction. It's just telling you that x is greater than 1. Because if you make x equal to 1, 1 to the power of any number is 1. So like 1 to the power of 3 would be 1. 1 to the power of 5 would be 1. So it has to be a number bigger than 1. Same thing with 0. If it was 0, 0 to the power any number is 0. And so it's just restricting it so that it works for this problem, okay? So that's not necessarily information that will hurt you or help you when solving this problem. This is just a kind of defining what x has to be, okay? So we have this. It tells you what a plus b is, which seems out of nowhere, but what you should be able to notice is this pattern right here. A squared minus b squared. That is a difference of squares. If you remember when we were factoring, like let's say you were trying to factor that, it would factor to x plus 2 and x minus 2, right? Difference of squares. So a squared minus b squared would factor to a plus b and a minus b. That's a difference of squares. And then it tells you a plus b is 2, so that means this you can replace with 2 times a minus b. And then you know that these are the same, so 2 times what is 16? This would have to be 8. And that's what this is asking for. What is a minus b? This would have to be 8. That's how you get a. That one is putting together property of equality that we learned with exponential, putting together difference of squares factoring, putting together laws of exponents is really a good question in some of the things we've been learning and putting together. Hopefully you're able to figure that one out. Okay, so that is laws of exponents. Again, your practice will be due Thursday. If you need extra time, you can turn it in Friday. I won't get to grade it till this weekend probably. So if you need till Friday, that's fine, but it's formally due Thursday. It won't be counted as a late grade if you turn in Friday. It is a quizzes. The quizzes code is here. Let me know if you have any questions. And then next week we'll continue by talking about solving equations. So that's it. Take care.